Hi, welcome to Chromatography Experts, a new podcast from Toso Bioscience Separation to Purification. In this podcast, we're going to explore chromatography from a technical, business, supply chain, anything you can think of. All chromatography will be here. I'm Anson Lewis, Global Sales Manager here at Toso Bioscience Separation and Purification.
And my name is Fu Duong. I am a Senior Global Commercial Strategy Manager at Toso Bioscience. So today, together with Anson, we're going to talk about chromatography topic.
Together, we'll walk through chromatography and introduce you to industry experts around the world.
Great. All right, let's have a conversation.
All right. Sounds good. So let's start with the basics. What is chromatography, Resin?
Yeah, so it's a good question. Chromatography, many people think about them, it's just like a matrix. And most of the time, these matrix are composed by beads, okay, small beads. And these small beads can be composed by polymer material, or it can be composed by agarose material. For example, at Toso Bioscience, the polymer that we make these beads are methacrylate material. And the methacrylate materials, you make big particle size, small particle size, and they all have different functionality, so they can capture all the interested molecules as customer or scientist needed to do.
Interesting. So, as a former scientist, lab scientist, I've heard a lot of different terms for chromatography, ion exchange, HIC. So, what are the differences between these things?
Yes, as I just introduced to you earlier, when you make these beads, you want to make sure that they have functionalities, right? And some of them, you can say that they are, you can make them positively charged or negatively charged, or you can put a live ligand on them, okay? That depends on the need of, for the purpose, like if scientists want to do what, so they can have options. And sometimes that they said, hey, I don't want anion, I don't want cation, maybe I want hydrophobic interaction material. So all of that, chromatography created for the purpose of capturing or purifying the material of interest.
As you know, this is a really expansive space that we work in biopharma and biotech. Can you explain a little bit about how the different resins kind of fit into different applications, whether it's MABs, oligonucleotides, things of that nature?
Oh yes, absolutely. You can see that, for example, MAB, the number one thing that, like the capture step, right? Because MAB is come from a cell line that sometimes they describe, in there, of course, the cell line express a lot of monoclonal antibodies. However, it also have other impurities in there as well. For that reason, like to purify MAB. And the thing is, you can see that MABs is a very, very specific molecules when it comes to treatment for diseases and things like that. So you want to have a very highly a purified material. For that reason, like, for example, to do capture for MAB, the first step that you do affinity, which is protein A resin and things like that, right? And after that, you can do polishing step. And the polishing step, that depends on what impurities that you need to remove. For example, if you want to remove high molecular weight, you could use, a cation resin. Or you want to polish, clean out all the endotoxin, you can use, an anion resin. So for that reason, chromatography has a different mode of separation get designed for each of the purpose, each steps of purification.
Understood.
Yeah.
So that sounds really, really cool, actually. So I hear capture step and polishing step, right? I'm capturing a molecule, and am I actually polishing a molecule? What's the difference between?
Yes. So the thing is, I mean, it means as the way it sounds. Okay. Yes. When you capture, it means that yes, you want to get a hold of the product of your interest. Okay. So capture step, that's about like you want to capture the product of interest. Most of the time, that's what you want to do. Okay. And of course, when you capture, you never have 100% of all of those products that you wanted.
Of course.
In there, you have some impurities. That's why polishing step is about. You want to make sure that you polish the product of interest. You increase more purity of the product. For that reason, that the term is using polishing. And most of the time, the polishing, you increase the purity of the product of interest, whereas you remove the impurities away from that.
Interesting. Okay. So now I'm going to put my business hat on, right? Because, obviously I work in sales. So can you explain to me the value of a resin used for capturing versus polishing? Are they similarly priced? Or are they similarly resourced? Like, what's the actual fundamental differences between the resins used in these steps?
Oh, typically for the capture step, if you talk about affinity, yes, pricing could be significantly higher compared to the polishing, the materials. Why is that? Because most of the time, creating a particles, a resin, a media for affinity purposes, you need to get involved with live ligand and not just, like material that you can synthesize, okay? So these, you make sure that you put, and ligand production is a very, very challenging process. And only that, you make sure that the capture step of affinity that is very specific. You cannot do a sloppy job by like using any ligand, right? You just have to be very, very specific. For that reason, pricing, you can see major differences.
Okay.
However, at Tulsa Bioscience, okay, we come up with, like product that, we want to make sure that we can reduce the cost. Because in order for us to reduce the cost, we want to manage, live ligand. We want to make sure that we source it right, okay? We have to make sure that we can produce in-house product. If you do everything, by get it from the third party and things like that, that's where the pricing increase significantly.
Okay.
That's why when people come to Tulsa Bioscience, there are a lot of options that people can select it.
That's obviously good to hear.
Yeah.
So obviously in chromatography, resin selection is a lot of things to consider. So how does particle size and pore size affect your selection criteria?
Yes. One thing that when come to particles or chromatography, the first thing that I always want to talk to people before, like the particle size, I want to talk about the pore size. Because the thing is that you want to make sure that you have to select the right pore size for your purpose. The key of purification here is you want to make sure you can capture all the product of your interest, right? And in order to do that, you make sure that the particles have an ability to absorb your molecule, hold it there until you're ready for your separation, and then you can manipulate the method to pour your product of interest away from the impurities. If you don't have a good pore size or the right pore size for your product, you will have a very low absorption, and from there your yield going to be low. Okay, so that's something that people want to make sure that. But why pore size so important? Just like you do filtration, you want to make sure everything have to get in, right? And then from there, that depends on its size. It can move accordingly. The bigger size, can move a bit, like faster. If like it did not have enough room for it to go in, instead of go everywhere in that pore size, sometimes it's so large it have to come right back out. Right? Or sometimes it didn't fit, it have to go out. It can go in. Where smaller one have to go in and stay in there. And take a little while to migrate to the next pores and the next particles and then coming out. And not only that, in the pore size, most of the time, that's where you place your ligand. Whether it's positive ligand, negatively charged ligand, or affinity ligand in there. So if you don't have a good selection of the pore size, you won't have a good purification. That's number one. And particle size, of course, just anything. If you select the particle size too small or too big, it will impact in your resolution as well. Typically, they said small particle size will increase the resolution. Just think about this one. You have more material to work with, and your product have to move so many different layers in there. And not only that, with a small particle size, when you pack them in a column, it packs tighter. So you don't have a lot of empty space in there. Because the empty spaces in there, it means your molecule have to migrate outside of the, like the outside and then go to the empty space and then move to the next one. So the term that I said, mass transfer, is not sufficient. That's why it's very diffuse, right? So you want to make sure that thing packed tightly, and most of the time, small particle size can pack a bit tighter, Okay, so one bead to the next, you don't have a lot of empty spaces in that. That's why things move in a tighter band, and you have a better resolution, put it that way. But if you have too big of the particle size, sometimes that you don't have like good separation, but also like sometimes sometimes your resolution a bit less. And not only that, sometimes that that you can lose some of the yield and things like that as well. Now, but there's a pros and cons of everything.
Of course.
When you work with small particle size, the back pressure will increase significantly. Whereas in the larger particle size, you will have less back pressure. So that's why when you come to Tulsa Bioscience, you have good selection. We have like from fine to small to medium to large particle size. That depends on your purpose. Then we can cater you accordingly.
One-stop shop.
Yes.
This is a question for our younger chromatographers, those who are just kind of starting out. You mentioned resolution a lot. What is resolution exactly?
Resolution is mean that you know what? I would make it so easy for you to see it. Just like the distance that me and you that we have here. Okay?
Good analogy.
So if like two of us so close to each other, it means we can touch our arms and elbows and things like that. And by doing it, you don't have a good distance. You don't have a good resolution, to put it that way. Why resolution has to do with purification is mean that the product of interest, if you don't have a good, migrating, like distance away from your impurity, it mean that when you collect your product of interest, you may collect some of your impurity in there as well. For that reason, they want to make sure that, hey, let's make sure one peak to the other have a greater distance that the resolution is about.
Thank you for the explanation.
Yes.
You also mentioned another thing about potential issues with back pressure. Can you explain a little bit why that's a problem, or that could be a problem?
Oh yes, because one thing about back pressure, when number one thing that limitation of instrumentation, right? And because sometimes as in production capacity, you don't want to run with a high back pressure. It's dangerous in the way that your instrumentation, like you don't want like create too much pressure in the column. And the other thing that with the high back pressure, it will prevent you to do fast work because you need to slow down the flow rate to accommodate, like that high back pressure. So from that standpoint, you can see that instead of doing, the double that flow rate, if you can do, let's say 10 ml per minute, but here you only can do 5 ml per minute, for example. And you can see that your work nearly have to become double amount of time. And of course, just anything, time is money. And for that reason, as like people want to make sure that they select the right materials for the right purpose. But sometimes they do need high back pressure for a certain product as well.
Understood.
Okay.
Understood.
Yes.
Thank you, Phil. Now we're going to take a little bit of a transition take a more of a zoomed out approach. So we talked a lot about the technical applications with our resins, and obviously we have a really wide selection of great resins to choose from. I kind of want to take a step back a couple of years ago with the pandemic. We had a lot of supply chain disruption. I know a lot of customers experienced a lot of pain working with, vendors with strained supply chains to get material. Can you speak a little bit to how TOSO has addressed that going forward and what advantages that TOSO offers in that space now?
Yes, I think that at Tulsa Bioscience, we have a thing that we used to say that we don't want to become a bottleneck of our customer. What does it mean by that? When you come to TOSO, when you order resins, okay, or anything related with chromatography, we want to make sure that we have a reasonable lead times, okay? We can deliver, many different locations in the world, not just United States, okay? So for that reason, we want to make sure that, number one, production plants. We have, like right now, we have 4 production plants, okay? The 5th one just about to come as well. And not only that, we have different locations of our production plants. Right now that, we have, in Japan, and we have in US as well, okay? And then beside that one, we want to make sure that we have location that we can store and ship the products. Like, for example, in Europe, we have the Belgium site that we can ship it out. In the United States, we have Ohio. And then, of course, we have, like in Singapore, we have multiple locations that you can store our material as well. Okay. And not only that, in terms of productions, we want to make sure that, like we understand the forecast from our customer because we build such good relationship with our clients. We want to make sure that they give us, communication is all about, okay? We understand, when they need it and like what they need so we can build our production accordingly as well.
No, awesome. Are there any future plans that you think TOSO's working on to further address this? Or I know one of the big questions a lot of our customers sometimes have is, all right, we want to partner with you, but we just want to make sure our supply is secure. Is there any future investments or anything you want to discuss about TOSO Bioscience to help assure our customers on that front?
Oh, yes. I think that, I wish that, my supply chain, manager is here, to talk a little bit more about that. But when it comes to supply chain, I mean, like one thing that we have a very strong structure of supply chain at TOSO, okay? Because the number one thing that we want to make sure that we have, visibility of all movements of our products. We want to make sure that, like it come across the border fine, okay? It did not hang up, somewhere that can be shipped. And more than anything that, of course, we produce our products, often ship and anything like that. We want to make sure that we have ISO protocol. And the ISO that's, allow us, like to support, GMP need. Okay, and not only that, all products that we make to make sure that we comply, right? And sustainability is a great deal with TOSO Bioscience nowadays. And the thing is, I guess we continue to invest in our production plants, as I just pointed out to you earlier. We, like as I said, right now we have 4 production plants. And the 5th one, and maybe the 6th one, like coming out, that depends on the need. But each of our production plants, we can do thousands and thousands of liters of, our resins, right? We have multiple locations. For that reason, that I think that continuity of our product is super highly, I mean, this is the priority of TOSO. We want to make sure that we can address all the needs of our customer.
Thanks, Phil.
Yes.
So that was a question that was more geared to our business and quality folks. I'm going to shift back now to our technical discussion. Can you discuss any future trends that you're seeing in the chromatography space and how TOSO might be trying to address that need with any new products?
Oh yeah, when it comes to future of chromatography, and you can see that, I mean, chromatography is when we talk, it's not just about resin itself, right? We have to talk about instrumentation. We have to think about hardware. You think about everything. So let me focus on a little bit about resin technology or purification technology. Because of purifications right now that you can see that beside resins, you also saw fiber technology. You can see membrane technologies, right? The question is, will you see more technology, like coming up? I have no doubt it will. But significantly near future, you can see a lot of improved process. Okay, what do I mean by improved process? It means that you can see more resin will launch in the market, have a higher dynamic binding capacity, or it can work faster. Okay, it can absorb things more effectively. Why is that? Because FDA have approved the platform with so many biopharma, and it's not as easy as accept a new technology immediately, but improve technology a bit easy, like for people to adopt. For that reason, I think that you can see new resin that have a high binding capacity. For example, at TOSO Bioscience with our Protein A, I mean clearly that years ago that like Protein A, 35 milligram per ml for binding capacity. But now you can increase all the way up to 70 milligram per ml. And only that, alkali stability and pH resistance is also a lot better nowadays. Because back then you don't want people to buy so much of resin because affinity material, as I pointed out to you earlier, is super expensive.
It is.
Right?
It is.
And you don't want to buy one and get rid of it. You want to make sure that it can recycle this, this resin for the next use. So you can see that a lot of improvement like that, near future, you can see quite a bit. And of course, like in terms of instrumentation or purification method, people do single columns, like a batch mold, but you will see more and more. Instead of do one column, they do multiple columns. Or that's why nowadays that you can hear that multi-column chromatography or MCC is out there. Even though it's not new anymore, it's been in the market for a few years now, but I believe that to reduce cost, to increase production and things like that, more of that will be implemented. Okay.
So I want to make sure everyone's heard here today, right? So I'm thinking about all those young scientists in the labs who could be currently doing resin screening or down the line in their careers working on resin screening, taking a lot of good notes on what you're saying. I think one question, how important and why is it important, dynamic binding capacity, DBC as I like to say all the time. Why is that important?
Okay, if you have to pick just one criteria, and I think that's a good one.
Yeah.
Because just like a few things that I keep telling people, okay? Why you select something that with low binding capacity? Because when you have a high binding capacity, because nowadays you can see that in terms of protein production, map production, you have such good titer. Years ago, maybe that you make a very little bit of an amount, but now you can select a cell line that can make a lot of maps. So of course, you want to have something with very high binding capacity, so it can carry that load or it can capture more materials, right? And by doing it, also, like as I pointed out, you can reduce the cost of your operation. Instead of binding, like as I said, nowadays at Tulsa Bioscience, if argon protein A can go up to 70 milligram per ml of resin for the binding capacity versus the 35 gram per liter or 35 milligram per ml, and you can see that why you have to use that product when you can use the resin can have that double capacity. Okay, so for that reason, dynamic binding capacity is one of the criteria that most of the time scientists, when they develop chromatography method, they want to work with that.
Okay. And obviously, working in sales, I'm very excited about our new Protein A, and I'd love for you to speak a bit more about why this resin is so exciting and how it technically is a little bit of a differentiator from those already in the market.
Yes, because as we discussed earlier, the number one thing that with our material specifically, that Protein A resin, alkali stability is just amazing. Okay, because by doing it, you can clean, you can do everything, and you can reduce the resin. And by reduce the resin, yes, you can see that not only like the product purity is gonna be good because you don't have a lot of junk left behind, and by doing it, like you don't have to buy resin so much. Okay, you reduce that, and with this high binding capacity, as I pointed out earlier, you reduce the amount of work that you have to do. Instead of do like 2 purifications, like, and each take 4 or 5 hours. But here, you can reduce nearly 50% of that because the binding capacity nearly 58% increase compared to years ago with our old Protein A resin. Okay, and the other thing that one thing about our philosophy, we want to make sure that we can control pricing. Okay, and by making product in-house, and by doing it, when we pass it on our consumers, we want to make sure that it's reasonable price rather than like, because you can see that Protein A nowadays going out on the market, I mean, it's one of the most expensive one. Yes. So at Tulsa Bioscience, we have a different philosophy. We want to make sure that we support the market with a very reasonable cost, okay, because we need to balance that.
So Fu, thanks again for speaking all about our resins and stuff like that. So I kind of want to zoom out a little bit for for our process engineers who may be working across the entire bioprocessing process, right? Who might work with filtration and violent activation. Can you kind of speak to, from an economic standpoint, why is resin so expensive compared to like maybe the filtration side. As a sales manager, I've worked across the entire processing process, and I noticed that chromatography resin tends to be a bit more expensive than the other parts. So can you explain a bit why that is precisely the case? Or
You know what? Honestly, I don't think that resin or chromatography is overly expensive.
okay,
Okay, because as I pointed out to you, I mean, the cost that you pay to have a high quality product. Because the thing is, efficacy of the products is super important for human health and things like that. And more than anything, I mean, I can see that others, materials, even more significant, expensive than chromatography itself. Because chromatography, not only, you can, clean up your drugs impurity, but also, you can reuse them, okay? I'll give you an example. For example, instrumentation. You can buy and you can use it, 10, 15 years?
Sure.
It shouldn't
Yeah.
be a problem.
Mm-hmm.
And then, for even at Tulsa Bioscience, even come down to our pre-packed columns. I mean, yes, we want to cut down the cost of, our customer. Because why? When we vision that, when you have a group of scientists going in, you want to make sure that, they're making drugs, and not worry so much about packing the column. So by doing it, we also reduce a lot of costs. And the product also is, available for you. Instead of the team that I have to, go in and pack the column and do the whole thing like that, just focus on the science part and then let us worry about, the supply, for you, right? And normally that you can see that the cost of, raw material for, or development of R&D is significantly higher. Because people only see an upfront dollars that they spend for chromatography, they think it's expensive. But actually it's not as expensive, during the process that people can see.
Understood.
Yeah.
Understood. Thank you for that, Phil.
Mm-hmm. All right, now I want to turn the table a little bit.
Of course, that's what we're here for.
And as the global sales manager,
Yes.
right? One thing that people always want to know from, of course, this one from Tulsa standpoint, how is our sales team work with our customer? Because the thing is, one thing that I knew for a fact that sometimes people I heard at conferences and things like that. Is it necessary to have a global sales structure, or a sales people even out there? Right. So talk to us a little bit about that.
No, it's a great question, and it's one obviously I think is probably pretty topical in this industry as a whole. For me, I think it's very important to have a global sales force for numerous reasons. Number one, our entire function revolves around supporting our customers, not just to provide product information, because you're right, you can get onto a website right now and look up a lot of the technical details of information if you actually needed to. Their jobs is to help find and develop solutions for our customers. We have an extensive network of salespeople globally, along with associated product managers and product specialists that work together to develop and really try to get to understand what our customers are kind of experiencing. Obviously, I used to work in a lab. I understand people are very busy. We spend all day, running samples, generating data, reporting it up to our superiors, and especially nowadays, when the pressure to continue to make quality drugs being evident by our aging population and things of that nature, that pressure has only been exacerbated over the last 10, 15 years. So the importance of a global sales force is to make sure that we help alleviate and help our customers by taking some of that burden off of them. Hey, let us know what you're experiencing. We have a great network of internal scientists and people, such as yourself, right? that can help develop and craft custom solutions to help our customers. Because as we said, it's not just chromatography resins, it's columns, it's instrumentation, it's the entire solution, right? We're not just here to sell you a product, we're here to sell you a solution that will enhance your process. So,
I see, mm-hmm. That makes sense.
Great question,
yeah.
Great question.
One more question,
of course.
Okay, and I think that this one is from, sales standpoint, mm-hmm. Okay? What do you see in the market now, particularly biopharm market, if you have to segment,
Yeah.
biopharma, how would you do that?
Great question. So when it comes to chromatography, I think one of the things that we've seen over the past few years is, while there's been a lot of emerging technologies, I think like cell and gene therapy, that was a really hot topic and still is a hot topic. There's been, obviously there's been scale-up challenges associated with cell and gene therapy. For us, the mAb space has been and it continues to be our dominant space when it comes to chromatography placement, right? So we see a lot of our big customers, without getting into names or anything, we see continued growth in that space. And while a lot of these emerging technologies, really do pose like a long-term growth opportunity, mAbs is really the bread and butter, as I would like to say, when it comes to our chromatography space. In addition, though, oligonucleotides is probably our fastest growing space, as you are well aware of, right?
Yeah.
So that's a really exciting space. A lot of our big customers, have continuously told us their expansion efforts seems to have no bounds. They're adding more capacity, it seems like, every single year. So a really exciting space to be in when it comes to oligonucleotide. And obviously, infectious disease continues to be, a focus of ours. So the vaccine space will always continue to be a strong presence for us. So all in all, it's pretty well diversified. So it's something that I think is really cool for our business. But from a technical standpoint, a lot of those those emerging technologies, as I mentioned, like cell and gene therapy, oligonucleotides, even as it is one of our fastest growing, it's still pretty early. We still have a lot of runway there. So it's a pretty exciting space to be in.
What about biosimilar? Do you guys see a lot of those?
Yes, we do see a lot of those as well. Like I said, I want to limit the specificity when it comes to some of that, but that's also a space. And think about it, especially considering the U.S. market, we have think about a lot of our big customers, without saying names, have patents expiring on some of their blockbuster drugs. So this is, I think that's the great point, Fu. That will continue to be a really big growth driver and a place to kind of keep our eyes on into the future.
So, like I say, one thing that I know for the fact that yes, people want to pay less.
Of course,
right?
As they should.
So biosimilar, is one of the solutions.
Absolutely,
for now.
absolutely.
Okay, that's great.
Absolutely.
When come to, those markets, okay. So you think that your team have enough capacity to support, all the needs?
Of course, I'm certainly not going to say no. But I think, with chromatography, the kind of the business cycle of it, it's a little bit different than a lot of what people would think is traditional sales, as you know. Our resins have to be screened at the laboratory level before it even gets into a manufacturing process, and the scale up of that is dependent on a lot of factors. Obviously market demands, the capacity of our customers, whether it's personnel wise, infrastructure wise, all of that has to play into it. So our team's ready. We take a great deal of pride in making sure our team is ready to meet the challenges of the day. So I'm excited for the opportunity. I know the team is excited to go out there and tackle opportunities. We participate in a lot of really exciting markets. Obviously, we have Boston here in the U.S., the Bay Area, and a lot of cool places. Silicon Valley, where we are currently right now, here in the Philadelphia area, and obviously globally with a lot of their emerging efforts, in Europe as well. So I'm really excited and the team is as well, to go ahead and tackle some of these challenges.
So it means that, if you need any support, let him know.
Yeah, we're here.
His team, more than capable to support all of their needs.
Absolutely.
Yes, great.
Absolutely. So I just want to kind of revisit a topic we talked about earlier. We mentioned about all the different types of resin modes that we kind of work in: ion exchange, affinity. We didn't touch on mixed mode. Can you kind of touch on that and how TOSO Bioscience offers solutions in that space?
Yes. You know what? That topic is very, very close to my heart, put it that way. Because I am always kidding around with a lot of people. When you go, to mixed mode, nearly you buy one, get one free, right? Because at TOSO Bioscience, the product that we have that a lot of interest is called Capture HA. Well, you may see this at the back. Yes, correct. Yeah, and this one is we produce in United States. Okay, in Ohio, and we have the facility there. Okay, why this one? Quite interested and it's so close to my heart because I find that yes, composition of this product is rather simple. It's calcium and phosphate, so that has both negatively charged and positively charged, chemistry in there.
Yeah.
So depends on, your need. You can use both of the charges, right? And not only that, if your material needs affinity, like calcium affinity or phosphorus affinity, this also, can do as well.
Oh, okay.
Okay, and the thing that I also like about is I'm not sure about other vendors, but for Tulsa Bioscience, this is one of the product that we make in the United States, and we so proud about that. Okay,
Of course.
And by doing it, it means that we can reduce the cost significantly. Okay, because of the thing that we don't have to OEM, this product, in-house product always, driving the cost significantly lower, okay? And the other thing that when come to this material, since we produce in-house, so we are the expert of the product. So if you or your customer have any question about that, just make sure that they understand it, and then make sure that they know that we have the expertise in-house. We can support it successfully.
So inexpensive and great support. Sounds like a customer's
Exactly.
dream.
And we make it.
No, of course, made in the
in-house.
USA.
Yes,
Awesome.
correct. Yeah.
So yeah, now that thanks for the explanation on that, Fu. So what are some of the uses of hydroxyapatite?
Oh yes, hydroxyapatite. The applications are very, very wide, right? The number one thing that when come to polishing step, you can use it for polishing your antibodies or maps. Okay, and it have great affinity for example, DNA and RNA. Okay, so a lot of people also use it for vaccination, purification purposes.
Gotcha.
For example, if you have an RNA or a DNA, particularly those that using vaccination, this product is great for that as well. Okay, or you have a protein that your protein is very picky in terms of pH selection. For example, for some reason that you cannot do super low or high, like anion and cation, and you want to do a neutral pH and things like that, or close to neutral, this resin also designed for that as well. Okay. Yeah. So I think that when come to they call KPHA, which is hydroxyapatite. Sometimes you can hear that. It has a very wide applications that scientists can use it for.
Fu, thanks again for joining us today. Obviously, you're a wealth of knowledge, and you're a great asset, obviously, to Tulsa Bioscience Separation.
Well, it's great to speak with you today, Anson.
And thank you all for joining us. It was a pleasure, and like I said, stay tuned for more episodes to deal with chromatography around the world.